question number 3 of chapter 4 series. Now in this video we are going to discuss dependence of rate. Here by rate I mean rate of reaction. On which factors the rate of reaction depends on. So rate of reaction depends on concentration of reactant and product. And so rate constant also depends on concentration of reactant and product. Here you can see the simple reaction is written A plus D gives C plus D. Small a, B, C, D are the moles respectively. So rate of reaction is directly proportional to concentration of reactant A and B raised to power X and Y. Here X and Y are practically derived value. It cannot be derived theoretically. So here I have written X and Y. They may or may not be equal to small a and b. A and b that are moles, they are may be equal or may not be equal to X and Y. Here instead of rate I have written the formula. Yesterday we learned instantaneous rate of reaction. That formula I have written here. Minus dr by dt, that is proportional to concentration of A and B raised to X and Y. If I remove this proportionality constant, I have to put K is constant here. K, that is rate constant. Again, this K is known as rate constant. So here I have written rate constant depends on concentration of reactant and product. K is rate constant, and this formula, last formula, that shows relation between rate of reaction in terms of concentration of reactant. Again, it shows relation between rate of reaction and concentration of reactant. This formula is known as rate law. Again, this formula is known as rate law. So, what is rate law? The formula which shows relation between rate of reaction and concentration of reactant. It is known as rate law. Okay. Now, here some examples are written. You can see here the first reaction. 2NO plus O2 gives 2NO2. For that reaction, if we want to write down the rate of reaction, so rate of reaction is equal to K, that is rate constant, into NO, concentration of NO raised to 2 into concentration of O2. Here X and Y means 2 and 1 that are equal to moles, you can see here. But in second reaction, you can see CXCl3 plus Cl2 gives CCl4 plus HCl. Now here two reactants are here, CXCl3 and Cl2. So rate of reaction is equal to K into concentration of CXCl3 into concentration of Cl2. And here power is 1/2. Also the mole is 1 here, mole is 1 here, the power is 1/2 here. So here concentration of Cl2 is different than power. Now third reaction, CH3COO CH2CH3 plus H2O gives CH3COOH plus CH3CH2OH. It is esterification reaction. Now here you can see rate of reaction is equal to constant into concentration of first reactant into concentration of second reaction raised to power 0. Power is 0 here. So this reaction depends on only one reactant, that is ester reactant. It does not depend on water. So here you can see X and Y, the power that can be equal to moles or cannot be, may be equal to or may not be equal to the moles. Now the next topic is order of reaction. Now this topic is very important for board exams. order of reaction. So first consider the reaction. A plus B gives C plus D with moles small a, B, C, D respectively. Now for that reaction, if I write rate of reaction, so rate of reaction is equal to K, that is rate constant, into concentration of A and B with power X and Y. That formula we learn. Now here addition of X and Y means X plus Y, that is overall order of reaction. Again, addition of X and Y, X plus Y is equal to overall order of reaction. If I consider only X, so X is equal to order of reaction with respect to reactant A, because it is in power of reactant A. So X is equal to order of reaction with respect to reactant A. Y is equal to order of reaction with respect to reactant B. Y, that is power of reactant B, so it is order of reaction with respect to reactant B. Now next point is order of reaction can be 0, 1, 2, 3, etc. or even a fraction. You can see the example. Suppose I have a reaction for that rate of reaction is equal to K into concentration of A raised to 1 by 2 into concentration of B. Now order of reaction is equal to 1 by 2 plus 1 X plus Y. So 1 by 2 plus 1. So I will get 1 and 1 half 1.5. So here order of reaction is a fraction. Now reaction in which order of reaction is equal to 1. Again, reaction in which order of reaction is equal to 1, they are called elementary reactions. Elementary reactions. And other reaction in which order of reaction is not 1, they are called complex reactions. So these two definitions are there: elementary reaction and complex reaction. Elementary reaction in which order of reaction is equal to 1. Complex reaction in which order of reaction is not equal to 1. Now, if we derive order of reaction is equal to 0, then the reaction is called zero order reaction. If we derive order of reaction is equal to 1, the reaction is called first order reaction or elementary reaction, like the definition. If order of reaction is equal to 2, the reaction is called second order reaction. Now, if reaction or order of reaction is equal to 3, the reaction is called third order reaction. Like that, so on, the name is given to the reaction. Now, here we are going to find out unit of rate constant K. Rate constant K no unit find out करवाना है. For that, here I have written rate of reaction formula. Rate of reaction is equal to K into concentration of A and B with X and Y power. Now we know that X plus Y is equal to order of reaction. Suppose it is small n. So small n is order of reaction here. I can make formula for K from this one. K is equal to rate divided by this both concentration. So rate divided by concentration. Now unit of rate. Yesterday we learned unit of rate, that is concentration divided by time. These both are concentration. So 1 divided by concentration raised to n. What is n? N is equal to X plus Y here. Now if the reaction is zero order reaction, again if the reaction is zero order reaction, so here instead of n, 0 we will put. So here I have written for n is equal to 0, zero order reaction, K is equal to concentration divided by time into 1 by concentration raised to 0. Concentration raised to 0 means 1, so I will get concentration divided by time. If the concentration is in molarity, then mole per liter into time is that, so second. So this is the unit of K when reaction is zero order reaction. Suppose our reaction is first order reaction. So what will I do? Concentration divided by time into 1 by concentration raised to 1. Instead of 0 here, I will put 1. So concentration divided by time into 1 by concentration will be here. Concentration will be cancelled out. So I will get unit for that 1 by time, that is second inverse. Like that, for all order of reaction you can derive the unit of rate constant K.